Hello everyone, welcome to another video for Mathematics of grade 11. In this video, we are going to start chapter 7 of your book. And the first section of this chapter is about law of sines and law of cosines. So, in grade 10, you learned about trigonometry. You learned about the definition of the trigonometric functions like sine, cosine, tangent, and you had some of the trigonometric identities about them. Now here in this chapter, which is the main focus of this chapter, is about just trigonometry. We're going to use the tools and concepts that you learned in grade 10 and apply them to some questions and build some more trigonometric concepts and ideas in this chapter. So the first section of this chapter starts with two very useful and very important laws in trigonometry, which are called law of sines and law of cosines. In this video, we are just going to concentrate on the first law, which is law of sines, and in the next video, we will continue with law of cosines. Alright, so what is law of sines? Suppose that we have a triangle like this one over here. It's like a general triangle with a vertex of A, B, and C. So it's customary in geometry that if a vertex is given by a capital letter like A, then the side opposite to that angle will be given by little a of the same letter, right? So here you will have the uppercase letter. On the opposite, you will have the lowercase letter, which indicates the length of the side. Okay, so in the same way, here you have capital B, so in the opposite, you will have little b, which indicates the length of this side. Capital C here, and opposite, you will have little c, which indicates the length of the opposite side. So it is customary in geometry that this angle will be a lowercase letter, and the opposite side will be given by this. Sorry, here you will have uppercase letter for the angle, and the opposite side will be the lowercase letter of the same type. So let's imagine you have a triangle like this. Then the law of sines, it reads like this. It says if you choose a vertex like A here, and just look at the side opposite to that one, it's given by A. If you divide this little a by the sine of that angle, so A divided by sine A, then this ratio is equal to dividing B, the length of this side, by the sine of the opposite angle, and this ratio is equal to dividing side C by the sine of the angle opposite to that one, C over sine C. So in any triangle, any scalene, isosceles, equilateral, or right triangle will have this law, which is called law of sines. So choose a side, divide the measure by the sine of its opposite angle. That must be equal to another side divided by sine of the opposite angle, and that is equal to the third side divided by sine of the opposite angle to that one. So this is called law of sines. Which is a very useful law. We will use it in many questions, and it will facilitate the solving process of many questions in trigonometry. So let's see how we can use this law in real examples. The first example says find the side length df. Df is this one. Okay, so how can we find the length of df here? EF is given by 18. We know two angles here, and we're going to find this side length, which is df. So if you remember the law of sines, it says EF divided by sine of 105 equals df divided by sine of 32. And notice in this shape, the third angle and the third side is irrelevant to us because nothing is given here and we don't need that. So just these two will be enough for solving the question. So let's do that. So I'm going to call the side DF by little e, okay, which is opposite to angle E. I'm going to find the value of E. Let's write the law of sines here. So it says EF over sine of 105. This must be equal to DF divided by sine of 32. Okay, so let's replace the values. From this one, we will have, so side EF is given by 18 divided by sine 105. This must be equal to, DF is unknown, so we called it E over sine of 32. So notice here that these two values are known here. You can easily use a calculator to find the value of these two, the sine of these two angles. So the only unknown that we have in this equation is that little e here. And so you remember that whenever you have a rational equation like this one, the cross product will give you the answer, right? So let's just cross product here. E times sine of 105. This is equal to 18 times sine of 32. And now we should divide by sine of 105. So E equals 18 times sine of 32 divided by sine of 105. And now by using a calculator, you will find that this is about 9.88. So this is the value or the side length of DF. All right, next example. So in this one, question says find the measure of angle S. So angle S is over here, so you want to find the angle size this time. It's not a length, it's a sign, it's an angle size. So looks, this one, T is given by 75, this side is given by 7, this side is given by 5, and now we're going to find the measure of this angle. Again, we can write down the law of sine, and that's promising because sine of this over this equals sine of this over this one. By the way, notice that I just used here sine of this over this equals sine of this over this. So there is no difference because whenever you have A over B equals C over D, this is the same thing. So it's the same thing as saying B over A equals D over C. Okay, so in the law of sines, we had A over sine A equals B over sine B. So you can easily say this is the same thing as sine A over little a equals sine B over little b. In fact, in some books they use this one to demonstrate the law of sines. They are the same thing. Okay, so let me erase these things to make room for the solution. Okay, so now let's write the law of sines here in this triangle. It was, let's start with RS. So RS divided by sine of angle T. This must be equal to RT divided by sine of S. Let's replace the values that we have here. RS is given by 7 units divided by sine of 75. That must be equal to 5 divided by sine of S. So, and this sine S is the thing that we are going to find, right? So again, we have a rational equation, so let's go by cross product. So 5 times sine of 75 equals 7 sine of angle S. So let's single out sine S here. sine s equals 5 sine 75 divided by 7. So again, by using a calculator, you will get the answer 0.689. It's a good advice here that I should give you. If whenever you have such an equation, try to include at least 3 decimal points, because that will give you an accurate answer for the angle S. All right. So now again, if you remember from grade 10, if you have sine of an angle equal to some number like 689, you can recover back the angle by inverse operation. So angle S equals sine inverse of this number over here. So we need to take sine inverse of 0.689, which is about 43.6 degrees. Okay, last question for this video. Let's say, what is it all about? It says find the length AC, this one over here. So again, we need to write the law of sines and then figure out the length of this sine. So let's just write the law here. I'm going to denote this AC by little b. So it is like b over sine 67 equals, and that is equal to 18 over this angle. But you notice that here this angle is not given, but that's not a problem here. We can easily find the angle because they have to add up to 180, right, in a triangle. So this one is 44, this one is 67, so this one has no choice but to be 69, right? So that the law of sine becomes b over sine of 67 equals 18 over sine of 69. So now again we cross product. B sine of 69 equals 18 times sine of 67, which gives us B is equal to 18 sine of 67 divided by sine of 69, which is equal to, I can use a calculator to find the answer. It's about 17.7.